Hello, this is Mr. Win, and this video is about graphing polynomials. So when we're graphing polynomials, there are many important things we're going to include, such as the x-intercepts, roots, or zeros. We can find that by just setting y equals 0 and then solving for x. We also want the y-intercept. We find that by setting x equals 0 and solving for y. Then we need the extrema, or maximums, minimums, and turn points. Now, unfortunately, without knowing calculus yet, we can't calculate these by hand for degree 3 or higher, so we have to rely on a graph calculator to find those for us, and I'll show you how. But if it's a quadratic, you can do vertex axis symmetry, plug it in, and then the direction of the graph. And you can find this by just plugging lots of x's to find other points, or you can use end behavior knowledge and multiplicity of roots knowledge, which is what we'll focus on. So first, let's talk about end behavior of a polynomial. Like the name suggests, end behavior is talking about what is happening at the left and right ends of a graph. Its notation looks like this. You'll see this f of x, arrow, like some infinity sign. Alright, so this says f of x, the y value, approaches positive infinity, meaning it's going up as x approaches infinity. So as x is going to the right side, y is going up. Down here, f of x, so y approaches negative infinity, meaning it goes down as x approaches negative infinity. So as x goes left, y goes down. You read it backwards if you want. So it doesn't matter what this dotted line stuff is. We only care about the end, the left end and the right end. So over here, this is going up as x goes left, and it's going down, negative infinity, as x goes right. Here, as x goes left, y goes up. As x goes right, y goes up. Here, as x goes left, y goes down. As x goes right, y goes down. Alright, so you're basically answering these two questions. What is happening to the y value of the graph or line or curve while x is going way, way, way forever to the left? And then what is happening to the y value of the graph, line, curve while x is going way, way, way or forever to the right? Alright, end behavior for a polynomial depends on only two things. One is the degree, is it even or odd? And then two is the sign of the leading coefficient, is it positive or negative? So using those two things, there's only four total cases. Even degree positive, even degree negative, odd degree positive, odd degree negative. So here's three even degree polynomials with a positive lead coefficient. This graph is x squared minus 4. Notice it's a quadratic or parabola. Down 4 is going up because a, or the leading coefficient, is 1, and degree is 2. Here, the degree is 4. The leading coefficient, the number in front of that, is positive 1. It looks like this w. And here, this is a degree of 6, leading coefficient of 1, so it's positive. And it looks like this thing. Also notice this has one minimum. This has one minimum, or maximum minimum, so two minimums and maximum. And this is 1, 2, 3 minimums and 2 maximums. So there's 1 here, 3 here, and 5 here. Notice that number is exactly 1 below the degree. So 6 minus 1 is 5. 4 minus 1 is 3. 2 minus 1 is 1. But anyways, notice the end behavior is all the same. That is, as x is going to the left, y is going up. As x is going to the right, y is going up. So it's up and up on the left and right, up on the left, up on the right. Alright, so we can say y or f of x. Here's three even degree polynomials with a negative leading coefficient. So the degree is still 2. It's still a parabola, but now it's upside down. Why is it upside down? Because the a value is negative. If the leading coefficient is negative, which is a, you just flip the picture upside down. So here we have that w upside down. Here we have that weird thing upside down. Because here, degree is 4, leading coefficient is negative 2. Here degree is 6, leading coefficient is negative 1. Here degree is 2, leading coefficient is negative 10. But anyways, there's still all the same end behavior. And that is, when we go left, we go down. When we go right, y goes down. That should make sense, because we're just flipping the parabola upside down now. Instead of up, up, it now goes down, down. You're allowed to flip end behavior as well. Alright, let's do the odd ones. Here's three odd degree polynomials with a positive leading coefficient. So here's y equals 3x minus 2. Hopefully I know mx is b. Slope of 3, y ends up negative 2. So it's down 2, then it goes up 3 over 1, up 3 over 1. But look, on the left side it's going down, on the right side it's going up. Alright, here's x cubed plus x. On the left side it's going down, on the right side it's going up. Also, I should say this has no max or mins. This has two max or mins. There's one max right here, one min right here. That's 1 below the degree. This is degree of 5, so x1 is 4. There's 4 mins or maxes. There's 1, 2, 3, 4. So there's 2 maxes, 2 mins, and those are relative max and mins. But anyways, the end behavior is still down for the left side, up for the right side. So here it should be down and then up. Then if you make it negative, of course you flip it. So here's negative 4x plus 1. So the slope of negative 4, down 4 over 1, down 4 over 1, and the y-intercept of positive 1 or up 1. All right, no max or mins. Here, negative 3x cubed plus blah, blah, blah. It doesn't matter what the rest is. We only care about the term with the highest exponent. So the degree is 3, and its leading coefficient is negative 3. So 3 minus 1 is 2. There should be 2 max or mins total. There's one minimum right here, a relative min, one relative max right here. And it is going up on the left side, down on the right side. Here's x to the fifth minus 2x cubed plus x. Again, we only care. Ooh, I forgot to change that to negative. All right, so small typo. Let's add a little negative sign here. But I have the picture correct. So this has to be negative because it's up on the left side as x is approaching negative infinity, y is approaching positive infinity, y is going up. And then as x is going positive, as x is going right, y is going down to negative infinity. All right, but again, notice all the information is the same. It's up on the left, down on the right. All right, so the takeaways: even degree polynomials always have the same end behavior in the same direction. Odd degree polynomials always have end behavior in the opposite direction. So in case you didn't notice, here it was up and up, same way. Down and down, same direction. Those are both for evens. Then for odds, it's one of each. One's down, one's up, and there's the reverse. Here's up, here's down. All right, and then the number or extrema max min turn points is always one less than the degree. And here's a little chart for y'all. Even positive means up, up. Even negative means down, down. Odd positive means down on the left, up on the right. And odd negative means up on the left, down on the right. And when in doubt, think simple. I always think of just the parent function for quadratics and linears. I think of y equals x squared, y equals negative x squared, y equals x, y equals negative x. All right, now let's talk about x-intercepts and roots and multiplicity of roots. So you already know a real root will appear as an x-intercept. So for example, look at the function y equals x plus 2 times x minus 3. That is a quadratic with the degree 2. Remember, the degree tells you how many answers are, so there's two solutions. If you use the zero product property, so them equals 0, you get negative 2 is one answer, 3 is another answer. Here's the graph. Negative 2 is one answer, x-intercept, positive 3 is another answer. But what happens if a factor is repeated so that root or solution happens twice? So here's our new example. Y equals x plus 2 times x minus 3 times x minus 3, which sometimes they write like this. Y equals x plus 2 times x minus 3 all squared. All right, this is a cubic with the degree 3 because it's x times x times x. You just multiply all the first terms to figure out the degree. So there should be 3 solutions. Now if we do the zero product property, we only get 2 answers. We get negative 2, 3, and then the other 3 repeats. But because the 3 showed up twice, we say it has a multiplicity of 2. It appeared 2 times. And we even call that a double root. There's also triple roots, quadruple roots, and so forth. And you can also say the solution negative 2 has a multiplicity of 1. It showed up once. Now let's see what happens in the graph. So this should not be a quadratic anymore. It's not going to be a U. It should be that little S shape. So it is. Negative 2 has a multiplicity of 1 right here. And positive 3 has a multiplicity of 2 right there. So here's 3 more graphs to analyze. This equation, although it's linear, even the parentheses is unnecessary, but has an answer of 1, of a multiplicity of 1. 1 shows up once. Here the answer is negative 3 with a multiplicity of 2. So it showed up, here it is. Here, positive 3 has a multiplicity of 1 right there. Positive 1 from that second answer has a multiplicity of 2 right here. Negative 2 from the third factor has a multiplicity of 3, so it's right here. And negative 4 has a multiplicity of 6, so it's right there. So what should you notice? Hopefully you notice if it's an odd number for the multiplicity, it goes through the x-axis. It crosses over. If it's an even multiplicity, for example, this negative 3, it didn't cross the x-axis. It just touched it and then it stayed on the same side. We call it bouncing behavior. All right, so here 3 has 1, so it crossed through 3. 1 has multiplicity 2, so it bounced at 1. Negative 2 has an odd multiplicity, so it goes through it. Then negative 4 has an even multiplicity, so it bounces. All right, so some takeaways here. A root with an odd multiplicity crosses or goes through the x-axis. A root with an even multiplicity touches and bounces off the x-axis. And then the last thing is the higher the multiplicity, the flatter the graph looks at the x-intercept. So I didn't show that, but here it is. Here's x to the 405th power. This answer is 0. That's the x-intercept. 405 times has a multiplicity of 405. That's odd. So it goes through. That's why it crossed over. But it looks really flat. Here's x to the 400th power. So again, the only root here is 0, but it appeared 400 times. That's the even multiplicity, so it did not cross over. It stayed on the same side, but it did bounce, but it looks really flat. All right, let's put this all together in one problem. So we're going to graph y equals all of this. So the first thing I would do is identify the end behavior. So we're going to find the degree first. The degree, well, there's 4 of these, 2 of these, 1 of these. So this has x to the 4th power, this is x squared, this is x. So x to the 4th times x squared is x to the 6th times the next x to the 7th. Degree is 7, that is odd. So we know that the end behavior is going to be different directions. These are going to be up, down, or down, up, depending on the sign of the first leading coefficient. So how do we find that next? So we have to multiply all the first things, but be careful. There's 4 of these and there's 2 of these. So we don't care about the leading coefficient is 1. So 1 to the 4th power is 1. I don't care about that. This one is 3 squared. That's 9. Then 9 times negative 2 is negative 18. All I really care about is the negative part, but it is negative 18. It's negative. Because we have an odd negative, it should be up, down for end behavior. Next, we're going to try to find the roots of multiplicity. From this first factor, you said equals 0, you're going to subtract 5, divide by negative 2. A negative divided by negative is positive. So positive 5 over 2 has a multiplicity of 1. 1 is odd, so that means it's going to cross over through that point. Next, right here, we have 2 of these, multiplicity 2. If you study 0, you have to subtract 2, divide by 3, so negative 2/3 has a multiplicity of 2, that is even, that's going to bounce. Then this last one, set equals 0, just add 1 on both sides. It's 1, has a multiplicity of 4. And because 4 is even, that is going to bounce. Last, we're going to find the y-intercept. That's easy, just plug in 0 for all the x's up here. So this can be 0, so this can be 5 in the first parentheses. This can be 0, so this can be 2 in the second parentheses squared. This can be 0, so this can be negative 1 in the third parentheses to the 4th power. You figure out those exponents, so that's 5 times 4 times 1, which is 20. Alright, I'm now going to put all this on the graph. So notice I put 0, 20 as my y-intercept. I have the 3 x-intercepts, or solutions, roots, negative 2/3, 1, 5 over 2. Now I'm going to try to graph this. So first, we're going to use our end behavior. We know on the left side, we're going to be up. So I'm going to be up here somewhere. So I have to go down towards this negative 2/3. Once I hit here, I'm going to check. Am I crossing or bouncing? Negative 2 over 3 has mostly 2. It's even. It bounces. That's to bounce upwards. It cannot cross. It has to go up towards this y-intercept. But if we go back to the next answer, it'll start going down somewhere. I don't know where. Maybe it goes past higher a little bit and goes down. So this is a sketch. We're hitting 1. At 1, mostly the force is going to bounce again, so it's going to go up again. I don't know how high. And then we have to start going downwards back to 5 over 2. It's multiplicity of 1. That's odd. I have to cross over. So it goes down here. So here's my guess of a sketch, and it's pretty close. Notice this is odd end behavior. It is up, down, so that's good. I did graph this in the calculator to see how close I got. I typed it in. I go to graph. Let's see. So it starts on the top. It bounces, goes up. It goes down, then hits the y-intercept. It goes down here to 1. 1 is 4, so it's pretty flat. Then it goes up, and then it goes down again. Now this, I don't know how high this goes, but kind of close. To find the maximums, here's how you do it in a calculator. You're going to go to trace. Sorry, not trace. Second trace for calculate. Then you go either max or min for what you're trying to find. I'm going to try to find maximum. I'm going to try to find this max since it's not 20. It's actually above 20. It says left bound. You're going to go click left to move this little X spider thing to the left of the max you're trying to find. I'm trying to find this max right here, so I move the spider right here to the left. Click enter once. It says right bound, so you have to go right of this maximum. So I'm going to press right until I pass it. Now press enter. Make sure there's only one max between these two little lines. It will find the maximum of the boundary. So I click, it says guess, press enter. We know the maximum is actually 22.27. So this one should have gone up a little higher right here, then went down. Because the negative 0.14 was actually 22.27. And that's how you find everything. Alright, hope you enjoyed the video. Make sure you join the live sessions, ask questions. Thanks for watching. See you soon. Bye.